With neat diagram illustrate the IOC reference model suggested by Cisco. See, Cisco, IBM, Oracle, all the three they have suggested the framework, conceptual framework or reference models. Cisco has given the reference model. Reference model means 7 layers reference model they have given over there. Conceptual framework, IBM has been given and Oracle has been given over there. So those two are a little bit complicated, the diagrams, but your reference model is easy. What each layer will do, what are the components, what are the devices we are having in each layer, we can go ahead with that. Easily you can explain that one. First of all, you should define the IoT, Internet of Things, what exactly Internet of Things and all those things. You can explain it. So let us just go for it. IoT definition basically is a network of physical objects or things embedded with electronic software, sensors, and connectivity. Enables to achieve greater value and service by enhance exchanging data with the manufacturers, operators, and other connected devices. Each thing is uniquely identified through its embedded computing system, but is able to interoperate within the existing internet infrastructure. So the vision of IoT is where things become smart. What things? Wearable devices, alarm clocks, home appliances, surrounding objects, everything they become smart and function like living entities by sensing, computing, and communicating through embedded devices which interact with remote objects. So they are going to interact, or it may be through persons. Things become intelligent, smart, and behaving alive. That is the statement. What do you mean by Internet of Things? The things becoming intelligent, smart, and behaving alive. Now, before going for this, let me directly go for the conceptual framework, Cisco. Okay, IBM concept. This IBM. This Cisco leveled or layered, whatever it may be, reference model. All 7 layers. This is one a graphical 3D image. This is your 2D image. So you better write the 2D image. You write it down. Whatever each layer will be there. Layer 1, layer 2, layer 3, layer 4, 5, 6, 7. Each layer, the layer 1 is basically a physical device and controller. That is the things which are kept over there. What are the things we have kept over there? Sensors, devices, machines, intelligent edge, nodes of all types. So in 7th layer 1, physical devices and controllers will be there. That is Internet of Things will be there. What are those things? Will be having sensors, will be having devices, will be having machines, will be having intelligent edge, nodes of all the types. Next, in the second layer, generally will be having the communication devices. That is connectivity, we say that one. See here also connectivity, communication and processing units. What are the communication and processing units? Generally, they will be routers. This is router, switch, bridge, all those things comes. This is a switch. This is a router. Okay, this device image is a switch where we can connect multiple devices through cables. This is a router which can route to the different networks over there. So switch, routers, and bridges, all those things comes in this connectivity layer. That is the second layer. When you go to the third layer, edge computing. So edge computing and fog computing, data element analysis and transportation. Main purpose of edge computing is data element analysis. What are the data we are transmitting? We are going to analyze that one. And transportation, where exactly we have to transport that. So edge data element analysis and transformation. Next one is very important. The fourth layer is the storage. What all the data you have collected that need to be stored in a proper location. That is storage, we'll call that. Data accumulation is the fourth layer where we are going to accumulate all the type of the data, whether it's a text, image, video, audio, whatever it may be, that will be accumulated in the fourth layer of the Cisco, that is data accumulation. Next one is data abstraction, aggregation and access. See, data need to be abstracted, data need to be accessed by different users or different applications. So that can be done by your fifth layer called the data abstraction, data aggregation, and data access. In the sixth layer, which application is accessing that one? It may be a report format, it may be analysis format, it may be controlling operation. Say temperature, I need to access that one. I can prepare a report. Okay, there may be a floods, so you need to like forecasting. There may be floods over there. You can get the forecasted data and you can take some precautions over there. That is for analysis and also for controlling over there. And finally, the seventh layer, collaboration and processes involving people and business process. Once they get this chart, this diagram and this information, they can able to see to that one where exactly. Either they can telecast it, they can display it on the TVs as big screens, and they can share it, audio signal, video signal, or through internet, whatever it may be, they can go for. So this is what the Cisco 7-layer architecture model, okay, for your IoT. This is conceptual model, 7-layer model from the Cisco. That is for the first question. Reference model suggested by the Cisco. Define IoT conceptual framework. First, we have to define what you mean by conceptual framework. Then, with need frame structure, discuss all the steps of the Oracle defined framework. See the second question. See, I have given all the three types. You may get one, or you may get two, or you may get three also, depending on the randomly generated questions. You may get all the three. So you have to be ready for all. IBM also you should be ready. Oracle also you should be ready. Cisco also you should be ready. So IBM, how many layers, Cisco, how many layers, and Oracle, how many layers, you should know that, and based on that, you can answer the questions. Okay, and determine how IBM defined IoT concept framework will be useful for real world applications. So you should also mention that how exactly it will be useful for real world applications. So when you look into these were the IBM IoT, how many are there? 1, 2, 3, 4, 5. IBM is having 5. I 5. Okay, I 5. So you can recall that IBM is having 5 layers, 5 levels. That is sensors. Next is gathering the data consolidation. That is gather gateway data consolidation. Level 3, level 4 connect, collect, assemble, manage. So all these things will be done by different layers over there. That is IoT conceptual framework, IBM IoT conceptual framework. The equation below is an alternative conceptual representation for the complex system. What is the equation? Gather, consolidate, connect, collect, assemble, manage, and analyze. So this entire thing is going to be called as your IBM IoT conceptual framework. Similarly, when you go for the Oracle, this is the Oracle. In Oracle, we're going to have the 6: gather, enrich, stream, manage, acquire, organize, and analyze. 1, 2, 3, 4, 5, 6. These are the 6 uh, levels we can have in your Oracle framework. Oracle means 6, IBM means 5, and your Cisco means 7. The above equation is IoT concept framework by the Oracle. See, gather, enrich, stream, manage, acquire, organize. So you should know what are all the activities, what type of devices. Sensors will be there in the gather, gateways will be in enrich, communication devices will be there in your stream, and manage, you will be having a storage, then acquire, you'll be having the data centers, different types of data centers, and service management will be there in organize and analyze. So once you know this, it will be easy for you relate them. You can easily answer them. That is Oracle IoT framework and IBM IoT framework and Cisco reference model. All the three has been done. Next, standard for IoT framework. What are the different standards? I think this question is not there. Different IoT services has been asked. The service offered by the IoT services. So technology behind IoT, M2M communication. Let us see what are the services which are there. Okay, it's not there. We'll go for it. Just 1 second. Yes, you can go for this only. Even you can refer the notes. What are the different types of IoT services? We are going to briefly explain the services offered by the IoT servers. What do you mean by servers, IoT servers, and what are the different types of services offered by the IoT servers? We need to explain the modified OSN model for IoT MPM system. Modified model. Layers, 7 layers were there, it's been modified into 6 layers. So where it is, this is just for your information, technology behind. MTM, I'll come to that one later. Yeah, here we'll be having modified. 6 layers will be there. You need to answer that one. How exactly? OSI protocol means a family of information exchange standard development jointly by ISO and ITU. The 7 layers OSI model, but your uh, IoT and MTM has got the 6 layers. Data communication from device end to application, and they have explained about what do you mean by OSI. But when it comes to your IoT, we are going to have different. Physical has been changed to physical and data link. Data link has been changed to data adaptation. Network has been retained. Transport has been retained. Session and presentation has been changed to application support. And application has been given as application. So now this is very important. How exactly it is modified? Physical and data link will be having gather. Data adaptation will be enriching the data. Network will be stream. It's going to be next. Transportation also will also be having stream. Application support will take care of all the 3 different operations like organize, analyze, acquire, manage. That is manage, acquire, organize, and analyze will be done by your application support. So this is what the modified model for IoT and MTM communication. That is the question. This has been there in your son. List out the various IoT development platforms. Different platforms you have to go for that one. Software development tools, MTM architecture, technology. These are the different technologies which is called IoT frameworks. Platforms, you can go for what are the different types of platforms. You're going to have hardware. What do you mean by hardware? What are the different types of hardware we are going to have? See, development device, software, firmware. Somewhere I need to know that one. Just 1 second. There's some noise. Is there surroundings? Okay. Different types of platforms are these: Arduino, Raspberry Pi, Intel Galileo, Intel Edition, ARM Embedded, Bosch, BeagleBone, Black, and Wireless SoC. These are all the platforms where we can develop our IoT. Okay, different platforms are there. You can explain that. Briefly explain the differences between M2M and IoT. That is also very important. And MTM architecture. So all these things, what do you mean by MTM communication, MTM to IoT, MTM to IoT, difference, MTM, this is MTM architecture, here is the MTM architecture, it comes over there. So now the difference between IoT and MTM, we can get this. What do you mean by IoT? IoT has been explained here. IoT technology industry involves the integration of complex physical machinery, MTM communication with the network. So IoT and MTM is machine to machine without internet. But IoT means there should be an internet. Without internet, it will not work. See here. This is M2M. The close difference between MTM and IoT is that MTM must deploy device to device and carry out the coordination, monitoring, controlling of the device and communication without the use of the internet. Without the use of the internet, they are going to do that one. But whereas IoT deploys the internet, server, internet protocols, and server are cloud and application services or processes. All these things involves IoT. So you need to explain uh, here MTM to IoT, MTM to IoT. These 2 slides, 1 and 2. 1 and 2 need to be explained about it for difference between MTM and IoT. But when it comes to MTM architecture, there are basically MTM device domain, MTM network domain, and application domain. Device domain is at the bottom, network domain is in between, and application domain at the top over there. This is easy. Very easily you can go for it. So this is device domain at the bottom, network domain in between, application domain at the top over there. So you should know how exactly 3 domains of MTM architecture will work, what exactly device domain will work, how exactly network domain will work, how exactly application domain will work. So what are the different softwares you're using for your development tools? There are so many softwares are there, mainspring, communication, that is mainspring, flexible modeling, communication between devices, validation, normalization, long-term data storage, programming in Java, uses of the SQL. These are all the advantages for the mainspring over there. Mango is an open source NPM web-based software. It supports multiple platforms, multiple protocols, databases, meta points, user-defined events, and import exports. So you should know what are the different softwares and development tools meant for NPM. Examples of IoT, so many examples you can write on your own words you can write over there. Just have a look into this, then you can write on your own. Wearable smart device is one of the example. Smart home is one more example. Sensors and actuators manage the smart home. Wired and wireless sensors are incorporated into the security sensors, cameras, thermostats, smart plugs, lighting and entertainment systems. See, all these things you are experiencing on your own. No need to explain theoretically. As soon as you said what is the examples of IoT, you can whatever is there is surrounding you, you can write it over it. Okay, do it yourself. Sensors and actuators include smart plugs, motor detector, door or window detectors, smoke detectors, energy meter interface. All these things can be connected to internet and you can monitor them. You can control them. Okay. Remote control, using remote control you can operate. Using your mobiles you can operate. A connected home has the following applications deployed in a smart home. It may be mobiles, tablets, IPTV, VoIP, telephony, video conferencing. Everything can be done using your smart home. Home security is one of the application of a smart home. You can secure your home, access control and security alerts, lighting control, home health care. That is also very important. See, a lot of students they have done the project on this home health care. So a medicine box has been developed such a way that one a box will send an alarm to the patient saying that one, by this time you're supposed to take the medicine. This is the medicine you're supposed to take. Now, morning you take this medicine, afternoon you take this medicine, evening you take this medicine. So it's just like 10 minutes before it's going to give the beep sound or alarm sound, or it's going to add your signal. A smart medical kit. Smart medical kit, you will call that one. So home health care. If nobody is there to take care of the patient, this machine only will say that one today at lunchtime before the food or after the food you need to take this. So by 12:30 before food one alarm and says the message, and after 1:30 it says that when if your lunch is over you can take this medicine. So that is home health care we can go. One of the example of the home health care. Fire detection, leak detection, energy efficiency. In home health care you can go in the physical uh, way of this one, that is infrastructure healthcare. How exactly your home is there, whether it is secured, whether all the doors are locked or any door is kept open, whether gas is uh, locked properly or gas leakage is there, fire alarm. That is home healthcare. That is also one of the example of the home healthcare. We can say that it's not only a human's healthcare, even infrastructure healthcare also. Any leakage is there, water leakage is there, it should identify that one. Any fire accidents is there, it should identify that. Okay, gas leakage, all those things. Any lighting is been on without your notice, so it can switch off that. TVs. If assume that one when you're leaving your house, there is a power down, but once you locked it, automatically all your switches, lights, everything should be switched off. Once you enter, you're supposed to switch on that one, where you can save the electricity, you can save the health of the home. That is home healthcare, we will call that one. Solar panel monitoring and control can be done. Temperature monitoring and HVAC control, high voltage. Okay. Then refrigerator networking with maintenance, that is also can be controlled over there. All these things comes under smart home. This is what the block diagram. If there is a question, this block diagram need to be written by you. Neatly you have to draw. If you draw, you will get the good marks over there. This is home automation system. Home automation software, there are different types of softwares are there, and because each and every developer, as per their uh, expertise, they're going to develop using the different softwares and different hardwares also. Smart cities. This is one of the important question. The four-layered architecture for the smart cities given by the Cisco. The four okay, framework. You should know what is layer one, layer two, layer three, layer four. I'm stressing on this one. Maybe you may get this question in your examination. Kindly prepare for this. And four layers. Layer one, there is bottom layer, physical equipments or components. Second layer, get the data from those physical equipments and devices. Third layer, central collection services is going to collect all the information and it's going to store in the cloud. Fourth layer consists of the new innovative applications such as waste container management, only for the your smart cities I am talking about. This is applicable only for the smart cities. It has to check that one how exactly waste management can be taken care of, monitored, power loss monitoring, bike sharing management, smart parking, everything. So these so many things are there. In the top layer, one, see here, layer one, layer two, layer three, layer four. In top layer, all the types of the services can be given. In smart cities, I need a smart parking, I need a healthcare service, I need a fire service, I need a smart surveillance system. All these things are the application layer, that's fourth layer. For that one, all your storage. For that one, all the gather the information. Then the devices will be there. Very easy, four blocks you can write and you can write some text over there itself. Okay, different types of network, 3G, 4G, internet, Wi-Fi, GPS, Bluetooth, anything can be taken care. Modified OSN model I have given already. Okay, and explanation. What are the architecture layers in the modified OSN layer? Okay, that is the next one. Next one is data privacy, data enrichment, consolidation. So any data, if you're having, how exactly you can provide the security. Very, very important is privacy, security. And you have to enrich them. And you should consolidate the data, transformation, and data device management. All these things recently in the previous class I have explained this and how exactly a gateway is going to be played a very important role for this data enrichment and data consolidation. So gateway will be taking care of transcoding, privacy security integration, and also compaction and fusion. Transcoding means what? It's going to convert. Coding is going to be converted so that nobody should hack that one. It may be in the form of ASCII format instead of Unicode. It may be in the XML format instead of database, DBAMS. There are varieties of application for transcoding. Audio can be transcoded, video can be transcoded, where you can streamline that one to the destination. Privacy. Privacy means authentication so that nobody should hack it in between. Whatever the information you're having, that should not, even though it is hacked, it should not be get opened over there. So data such as patients' medical data, data for supplying goods in a company from one to other, and from and to the different locations, and changes inventories may need privacy and protection from conscious or unconscious transfer to untrustworthy destination using the internet. Nobody should hack it. Privacy is an aspect of data management and must be remembered while designing an application. Is very, very important. You should ensure that when whoever has given you the application development, they will ask, what is the security you are going to provide for my data? So a developer should ensure that 100% security, 100% privacy. If you don't say that one, then that product will be of no use. So the design should ensure privacy by ensuring that the data at the receiving end is considered anonymous from an individual or company. Following are the components of the privacy model: devices and application identity management, authentication, authorization, trust, reputation. Secure data, that is the third one. Data gathering and enrichment. There are four models are there. How exactly we can gather and we can enrich that one. First module is polling. Second module is event-based gathering. Depending on the event, you're going to gather that one. Okay. Then third one is scheduled interval. Fourth one is continuous monitoring. Whatever the data is there, you have to continuously have to monitor that one. Even though it has been shared, even though the data has been shared by source end and destination end, you're supposed to see to that one. Then continuously have to monitor that one. Refers to the data start from a device continuously. Example, data for traffic presence. Assume that when there is a traffic light signal is there. It should, what is the traffic presence? How much time the light should be on? If no vehicle is moving in front of the light, light should be switched off. I told you automatically light should be on and light should be off. That is what your IoT. Your IoT will take care of that one. Smart cities, smart lighting system. Data enrichment refers to add a value, provide a security and usability of the data. All put together is a data enrichment. Next one is data dissemination. Data dissemination, three steps for the data enrichment before the data dissemination to the network as aggregation, compaction, and fusion. So data enrichment, there are four types. There's a dissemination is of three types, three steps. Aggregation is the first one, second one is the compaction, third one is the fusion. Aggregation, the process of joining together present and previously received data frames. What do you mean by aggregation? I'm keep on getting the data one after the other, one after the other in a queue. Or one by one, I'm getting over there. But I need to pack them together. That is what aggregation. Because I cannot uh, show the data piece by piece to the destination. What are the source having a pack of data? As it is, the pack of data should be sent to the should be given to the receiver. But in between, it is step by step. I am receiving packet by packet. I am receiving itself because each packet is encapsulated, secured, and we have given the privacy, everything. But at the receiving end, whatever it was there, like that only it should come. So it should ensure that one. That is what aggregation. Joining together the present and the previously received data frames after removing redundant and duplicate data. That is what aggregation. Compaction, making information short without changing the meaning or context. So what happens now? Sometimes you can make because of the transmission, you can make it short, but you should not lose the information. Transmitting only the incremental data so that the information sent is short. So you no need to send the entire data each time. Only incremental data you send. First, I have sent three lines. Then I'm going to get what are the updations are there. Only updated data I will send. So it will increase the speed and also it provides the security and also compactness. As you send a part of the data, definitely speed increases. Fusion, formatting the information received in the parts through various data frames and several types of data, removing redundancy in the received data and presenting the formatted information created from the information parts. That means whatever we are received, we might have received piece by piece, but if you fusion that, neatly you have to place them. Aggregation is joining. Fusion means you have to present it neatly. Some duplicates need to be removed, noise need to be removed, and you should see to that one all the data has been received properly. Everything should ensure then only you can give the data to the receiver. It is used when the individual records are not required or not retrieved later. That is data enrichment and data fusion. Next one is IP, IPv4 and IPv6. I am concentrating only IPv4 and IP addressing. IPv4 already I explained about that. Basically, there are 32-bit header, IP header. The width is 32-bit. 7 layers are there. 7 steps are there. Totally 14 blocks are there. So in that one, you should know what are the size of each block. So to know the size of each block, this is the diagram. Because you are going to write like this only in your examination and IA, you should write like this. IP header 0 to 3 is your version, totally 4 bits. 4 to 7 is your header length. 8 to 15 is your type of service. 16 to 31 is your total length. So you should mention those things. Identifier is of 16 bit, flag is of 3 bits, and fragmentation is of 13 bit. TTL, okay, time to leave. Time to leave. How much time it should be there? Time to leave. What should be the life of that one? Time to LIVE. It's not LEAVE, LIVE. How much time it should be there in that particular data frame or header frame? Time to leave. Protocols, different types of protocols. Header checksum, any errors are there, it's going to verify that. So to do that, here it is the version, the theoretical value. The version, the first IP header field is a 4-bit version indicator. In IPv4, the value of its 4 bits is set to 0100. which indicates 4 in binary. However, if the router does not support the specified version, this packet will be dropped. Assume that the router does not support. It is supporting only IPv6. It will not support IPv4. So at that time, it will go for dropping the packets. Internet header length. Internet header length, shortly known as IHL, is 4 bit in size. It is also called H header length, HELEN. This IP component is used to show how many 32-bit words are present in the header. That is header length, basically how many 32-bit words are present. Type of service, various type of services we can provide over there. Differentiated services code point or DSCP. This field is provided features related to the quality of service for data streaming or VoIP call. It may be audio, it may be video, different types of data you're transmitting over there. So what type of data you're transmitting, what type of service you're providing, you should ensure that. The first 3 bits are the priority bits. It is also used for specifying how you can handle the datagram. Total length. The total length is measured by in bytes. The maximum size of an IP datagram is 20 bytes, and the minimum is 20 bytes, and maximum is 65,535. S length and total length can be used to calculate the dimensions of the payload. All hosts are required to be able to read 576 byte datagrams. Okay, that is what the total length. Identification is the packet that is used to identify fragments of an IP datagram uniquely. Some have recommended using this field for other things like adding information for packet tracing. IP flags. Flag is a 3-bit. See, I told you 3 bits. Field that helps you to control and identify fragment. The following can be either possible configuration: fragment offset, time to live, and protocol. Fragment offset represents the number of data bytes ahead of the particular fragment in the specific diagram. It is specified in terms of the number of 8 bits, which has maximum 65,538, 526, or 28. Time to live. Maximum time the datagram will be live in the internet system. Maximum how much time it can be there in the internet. See, I am downloading. Sometimes it will be say unable to download. So in between the packet was there in the internet. How much time it will be? Time out. Like that there is a message comes into picture. We are not in a position to download. Time out. Kindly refresh. Kindly reload. So time to live will ensure that how much time it should be there. Protocol. This IPv4 header is reserved to denote that Internet protocol is used in the later portion of the datagram. For example, 6 number digit is mostly used in the indicate TCP, and 17 is used to denote UDP. What type of protocol you're using, whether you're using TCP or you're using UDP, wireless, wired, connection oriented, connection less, acknowledgement based, all these things will be taken care by your protocol type. You may be using TCP, then you will get the acknowledgement. If you're using UDP, you will not get the acknowledgement. Error checksum, error checking. That is what your IPv4. Then you are going to have a source address 32-bit, destination address 32-bit, optional bits, and actual data. Actual data, it may be of 144 bytes, 256 bytes, depends. Okay, we'll be having the different size of the bytes. Next is IP addressing. I told you basically there are 5 different classes, address classes. This diagram shows that one, what should be the IP address for your class A, what should be the IP address for your class B, what should be the IP address for your class C. See, I told you maximum, see, D and E reserved for multicasting, and E is for experimental. Okay, when you go for class A, in that one class A, only the first octet will be used for the network, okay, range, and remaining will be used for your hosts. Means this is the organization IP. Assume that Infosys. Infosys is having some 50,000 components which are connected, devices which are connected. So one subnet mask will be there in 0 to 255, any one of that can be given. Then remaining 3 8 bits are allocated for the hosts. Similarly, there will be class B where we are going to use 2 octets for the network. Here 1 octet for the network ID and remaining 3 octets for the your devices which are connected. Okay. Here 2 octets for network and 2 octets for the devices, the things. In the class C, the commonly used small organization like institutions and all they're using, we will be using class C. 255, 255, 255, there, it's all these three used for the subnet mask and only the last octet used for your host. This octet is for host, this three is used for the network. D3, the class D, we are going to have the result for multicasting. Here you see 224 to 239. 224 to 239, only this much. Here 240 to 254. 15 addresses. Here also 15 addresses. Here we are going to have 192 to 223, some around 30, 31 and 32 addresses. Here going to have 128 to 191, 128 to 191. Here we are going to have 1 to 126. So like this, the IP addressing are classified over there. Based on the type of the organization, we'll be allocating the classes. It will be class A, it will be class B, it will be class C. Generally, there will be class C for the small organization, class A for the large organizations. And here you see 126 only, here 128 is there. In between 127 is somewhere missing. So class A address 127 cannot be used and is reserved for loop back testing. That is mainly used for maintenance and loop back. We are going to use that. So how it is? See in class A, there is one more diagram. First octet is for network ID and remaining 3 octets for the number of hosts. N number of hosts we can connect to. In class B, first 2 octets are for network ID and next 2 octets are for your host ID. In class C, first 3 octets for network ID and last octet for your host. Class D for multicasting, class E for reserve. So here, once again, is there 0 to 127 they are mentioned, but it's not 127, 0 to 126. 127 is reserved for your loop back. Okay, loop back. We are going to use that for testing or something. Subnet mask is 8 bits, subnet mask is 16 bits, subnet mask is 24 bits. Already we have seen. Means 24 bits are used for networking and 8 bits are used for host. 16 bits are used for networking and 16 bits are used for host. Here 8 bits are used for networking ID and remaining 24 bits are used for the host. So this is what IP addressing. And here once again it's been given how many network number of systems can be connected. For that purpose I given. See here 1 to 126. This is N means network address, H means host address. Network address is 128, 126. Host can be this many number of hosts can be connected. There is how many? 1 crore 67 lakh 77,214 different devices can be connected. Can be IP address can be allocated. So like this, we are having an Infosys or Wipro or globally if they're having, we can connect, give them. Second thing is 2 octets per network, 2 octets per host, 16,384. I think time up 4 o'clock. That's why it is. It is just 1 second. Is that 4? Another 2 minutes. I'll go for it. Yes. Since there was some slideshow, and that is the end of the slide. That's why. So network ID, there are n number of networks can be there. 126 networks can be there in your class A. 16,384 networks can be there in class B, and 20 lakhs networks can be there in class C. But it can be reused, but only 254 hosts can be there in that particular each network. If one network is there, in that network 254 hosts. Second network is there, in that one 254 hosts. Third network 254 hosts. Most commonly used network is class C. This is with respect to IPv4. But when it comes to IPv6, I'm not given IPv6 for the syllabus. because even in syllabus also they're not given that much information. So whatever the questions I framed, kindly see to that you will be answering those things. See this question number 15, 12, 13, 14 and 15. 14 and 15, you can answer easily. I have given data enrichment and data and consolidation also. Various data adaptation layer in a gateway, that also I have explained over there. Up to 15 questions neatly I have explained till now. Remaining, see to that you can answer, and even see 17th question also you can answer. What are the cloud platform based different conventional method, data collection, storage and computing? Define cloud computing and briefly explain the types of the cloud platform services, like platform as a service, infrastructure as a service, software as a service. You can explain what is a cloud service model, briefly explain. So be ready with this many questions. Those are eligible, they can attend. Those are not eligible, you have to wait, because a lot of things we need to consider over that. So, any questions from your end, you can ask.